Hi everyone. Today we're going to take a look at what's called molar volume. So to understand molar volume, there's a few things we have to look at. First is what's called STP. So STP stands for standard temperature and pressure. And this is just a set of conditions in which gases are held for an experiment. And this just means that the temperature is held at 0 degrees Celsius or 273.15 Kelvin and 1 atmosphere of pressure. In addition to STP, we'll have to recognize Avogadro's law. So Avogadro's law states that equal volumes of gases at the same temperature and the same pressure contain equal number of particles, and so which means that they have equal number of moles. So it does not matter what the gases are. If you have an equal volume of any two gases at the same temperature and same pressure, they will have the same number of moles and thus the same number of particles. Avogadro also determined that at STP, so again at 0 degrees Celsius and 1 atmosphere of pressure, 1 mole of any gas occupies a volume of 22.4 liters. And so 22.4 liters is known as molar volume because that is the amount of volume that a gas occupies if I have 1 mole of it at STP. So let's look at how this is used in an example. So we're asked here, what volume would 2.5 moles of oxygen gas occupy? And we're going to assume here that this gas is at STP. So once again, we're going to set up our table of given times want over have. So in this case, we are given that we have 2.5 moles of oxygen gas. Now we want to get the liters, and we currently have moles. And we have just learned that at 1 mole of gas at STP will occupy 22.4 liters. So then we get 2.5 times 22.4, and that equals to 56 liters of oxygen gas at STP. So that is one use of molar volume, being able to convert moles into liters at STP. And I just want to point out that at this case, 22.4 liters per mole is only applicable at STP. Should those conditions change, then STP and 22.4 will no longer be applicable. Now let's look at our second example here. How many moles of carbon dioxide are present in a 50-liter container? And again, we're going to assume here that we're at STP. So we set up our table. We have 50 liters of CO2. We are interested in moles and we want liters. So we've got that 1 mole of gas is 22.4 liters. And so 50 divided by 22.4 is equivalent to 2.23 moles of CO2. And there you have it. This is how we are able to convert the volume of a gas into moles at STP. And once more, if we are not STP, this method will not work. But 22.4 liters per mole is molar volume at STP. Now let's take a look at what we have learned so far in terms of moles. So if we are given the unit of mole, we have learned that we can convert moles into particles and vice versa by using Avogadro's number, 6.02 times 10 to the 23. We have also learned that you can convert between moles and mass by using the molar mass of a substance. Now we have just learned that you can convert between moles and volume, and if we are at STP, then we can use 22.4 liters per mole. What you're seeing here is called the mole roadmap. It shows you all the different conversions that we can do within the mole and the conversion factor related to it. So as long as we know mass, particles, or volume of a substance, we can find the moles of that substance. We just have to use the right conversion factor and, of course, determine whether we are multiplying or dividing by that conversion factor.